Hello everyone. So before move into what we are going to achieve today, let's solve a simple problem, right? Then let's see from there where we go. Okay. The problem is very simple. You can use any language. I like you to participate, right? This is a very simple problem. You have a folder. There is a file there. Maybe the file size is maybe 10 MB or 10 KB or whatever it is. So you have it's a kind of a novel or some kind of a document, right? So your goal is you need to find out unique words and how many times it's appeared in that document, right? That's the goal, right? So it's a very simple problem, right? Anybody wants to take a try, a shot how you would solve it? Anybody? It's okay.
So I'll first open the screen to read the file,
right,
and then try to read each word of the content of the file.
Each word, right?
Each word, and then
you keep
I need to store it.
Yeah, you keep it in the map,
Yeah.
So then set the count initially 1, yeah.
And then I compare with each string in that. So I need to do iterations over
for each word, right?
Word, and
okay,
then need
sure.
to find the duplicates and count.
Count, exactly. So essentially you have a hash map or some kind of data structure. You read a word and see if it's already there. If it's already is not there, insert as a count 1. If it is already there, get the existing count, increment, and then again put it back. So do it for all the words. At the end, you print the list of words and then equivalent count, right? So that's a simple problem, correct? So okay, so let's complicate the problem a little bit, right? So let's say folder contains maybe a lot of files, and then file size 10 GB is very small. Okay, so yeah, so 10 GB file size, right? So the same problem, how would you solve now? Yeah. See, you understand the problem, right? Your computer got 4 GB RAM.
Same logic holds good, but it takes time.
No, still it won't work. The reason is you got a 4 GB machine. Let's assume your laptop, right? So 4 GB machine, and then I'm talking about a 10 GB or more 100 GB also, correct? So to open the file, read records, and then compute, and then you have keeping the map, right, in the memory, main memory. So slowly it start eating your main memory. Then probably it will crash, right? Okay. Then how would you solve? Yes, this is we know. Yeah, please go ahead.
We can write a shell script to break that file. Say maybe I read just 100 file initially using the head command and then pass it to Java.
Exactly, that's good one. So using head command, you take the first 100 lines, you break into words and pass it somewhere. Again, next 100 line, then other files. You do all those things, correct? So now what are you doing? You are breaking, correct? Then splitting. Then you are producing intermediate results. That intermediate results again it will be sliced in the terms of if it's 100 GB, it will be again 100 GB. It's not less, right? Now again you need to sort it, right? Sorting also you cannot do, so you break that into small chunks. You sort the individual things. Again you use a merge sort. Again you merge it. So you do it iteratively over the maybe for months you do that. You develop right. You not write code. You understand, right? So then finally you get the answer, right? So it says you have to do a lot of coding. You agree with me? This is one simple problem, right? Let's change my problem to something else. Instead of word, maybe I need to convert into uppercase and then do that, something like that, right? So for each CPU cycle, it costs a lot of CPU cycles and a lot of disk space and then time and think about it. The amount of coding involved there, right? Okay. So the exact same thing, Google, went through their day-to-day life. So they have a lot of services. They keep generating data. So every group, they keep developing such a custom programs, running on some specialized hardware. Then keep generating output and then making the beautiful service Google search to you. So for all of us, so that is what they went through. Then they figured out that, oh man, so there is something going on. See, you're splitting it, you're doing it, solving small problem, then aggregating it, and then producing final output. You see, whatever you said exactly, that's what we need to achieve, right? So that's what the big data framework. So a lot of frameworks there. Google got something I know the name. Microsoft got Cosmos. Then open source one is the Hadoop. So these are all the things there. A lot of frameworks there. Hadoop is the one we are going to focus today. Right? Let's see the agenda today. So here, so I want to emphasize what is big data. So just giving introduction to big data and then properties of big data. Then we will look into the platform Hadoop. Right. So main focus is HDFS and MapReduce. Little bit we touch upon the Hive and a few other things, right? So by end of this class, you should know what is big data, why we need big data, what kind of problems you need to you can solve. Those kind of things you should be able to visualize and then apply your thoughts, right? Okay. So let's move on. Okay. So the data is goldmine. What does it mean? So now, if you look at any company, right? It's the telecom, Airtel, or Google, or Yahoo, or Flipkart, or whatnot. So any website provider or any service provider, they collect data, they keep it, they don't throw it away, they keep it for a long time, and then they try to make a lot of things out of it, right? So I'll discuss a couple of examples, and then we'll move on from there. So let's see this slide, right? So you have 4 types of records there, right? One is you went to a retail shop and placed an order. So that's the order is the record, the initial entries there. The order was the backend was processing the order. Something went wrong, some exceptions. So the middleware layer logged a message saying that something wrong. So there is an exception message here. Then you call. Okay, you haven't got your whatever you ordered. So what happened? You are calling a IVR or talking to an agent, and then complaining that you haven't got your things. They put you on hold, and then they are seeing why it's not delivered. They are not sure, right? So they are thinking about it. After that, you go to this is the standard and very popular practice that you don't like the company, you don't like their service, go and but their Twitter feed, right? So Twitter page, that's what it is. So you go there and say that you guys service is really bad. I ordered, you don't even deliver it, and you don't even respond to me. So you complain about it, and this is a negative PR. Nowadays companies are taking very seriously, right? So what the company could do? Okay, they can analyze the sentiment analysis. This is a free from text, right? What you have written there. So they can analyze what this customer is talking about. Is he happy, is sad, or is complaining, or is not received the product, or whatever it is. You can using a natural language processing, you can figure out. The moment they figure out that you are complaining about the product not delivered or something like that, they can go into other available sources and find out why it is not delivered, right? So if these things are not linked together. So before that, see, these things are linked together. Customer ID, Twitter ID, a lot of things are the common thread is there, right? So through which they can find out what went wrong, and then immediately they call you. We apologize. You will get your product in a few days. Okay, so problem is solved. See, that's the bottom line is, wherever you go, you leave lot of trail. So a lot of information without knowing you leave it. Let me give you another example that will give you better visualization. You go to any website, Best Buy or Walmart or whatever it is, right? So you think that you are browsing, you're selecting product, buy or don't buy, you move away, right? That's what you think. That's not the case. So there is a robot sitting there in your browser, JavaScript. So they keep watching, where you came from, your zip code, your machine, or your Mac or Windows or whatever it is, what browser you use, what internet service provider, what is the speed of internet service, then whether you're a previous visitor or new visitor, how many pages you visit, how much time you spend on each page, and what is your visit sequence. They monitor all those things, and they keep sending to the backend, right? Okay, so that's one thing. And also, so now what happens? So if you know that if you go to your, you visit a lot of Yahoo, Google, or whatever it is, right? So they have cookie. The unique cookie will be there. So Yahoo, it's called B cookie, right? You take the B cookie, and there is internal Yahoo system. You feed that system about this cookie, and it will tell you about your personality, right? What kind of person you are, what kind of things you might buy. They have complete detail. They built over a period of time. They have that. So all Google also has it, right? So they build a lot of things based on the collected data. So not only that, right? For retailers, so you made a previous purchase, correct? So they have purchase detail. Your social feed, right? Let's say if you log in with your a lot of companies, they ask you to log in with the Gmail or Facebook, right? So now they collect the social feed and then all those details. At the previous purchase, the internet, lot of information already available, especially in US. So you give the number, they'll give you where you live, a lot of details there. And also, like when you call or when you contact their support, sometimes you use Gmail, sometimes you use Yahoo Mail, or sometimes Hotmail, or sometimes you call from your landline, or sometimes your mobile phone, or sometimes spouse phone. So what they do is they have them. So you are leaving a lot of information here and there, and the data is going there, and they actually build the web around you. Then they know complete details of you, right? So one of actually at Microsoft, one of the executive, they were saying they were showing her details from what is available on internet. They were able to figure out where they live, how many kids, and what kind of hobby, what kind of car they drive. They are able to figure out just from the public information. So think about it, is you leave the a lot of trails, so they know a lot of things, right? So now, okay, what do I do with it? Yeah, I know a lot of things about you. What do I do with that, right? Okay, so next time when you call or when you go to a website, oh, this is a rich guy. I know he's buying habits. Let's target him. Let's give him some special attention, right? What do you mean by that? So they may change your background color or the product. From the history, they can they show you the product. Okay, upsell and cross sell. You familiar, right? You bought a computer, then probably you will buy a mouse, something like that. Or if you bought a computer, maybe you buy something on which sits on top of it. So they can predict, and also they know that okay, at what time they need to interact with the visitor. How to interact with the visitor, right? So sometimes by offering a coupon, 10% discount, you buy it. Sometimes offer a chat. Okay, you know what? Do you want any help in making the decision? They offer a chat, and then they probably it's proven that by engaging with the visitor at the right time, the conversion rate increases drastically, right? So that's why it's important that data is gold mine, and now every company, they collect data and keep it and store it. They process it. Okay, so you understand, right? So the data is gold mine, and wherever you go, people will keep it for a long time, and then whatever you do is there, right? So one simple example there, I prepared slides for a big data and then uploaded into my Google Drive. Within a couple of weeks, I got 2 calls, right? So the leading Hadoop trainer saying that you want to join us as a trainer. Come on, how could that happen? I never updated any of my profile about I'm interested in training or whatever it is. So I assume that Google pass my email and my content, and then they sell my email ID to these people, right? So that's the thing. So I'm sure that they would have sold my email ID for at least 1,000 rupees or maybe 2,000 rupees, right? So I don't know how much they sell, but yeah, that's what happening, right?
I'm sorry to interrupt.
Yeah.
I just have one question. The customer IDs, I can understand it's all in the same system,
right.
So it will be unique and it can be connected, right? But then Twitter is something that is
okay, so
personal to me, right? So I might have my.
No, it's not your Twitter. It's company Twitter.
Okay.
Company. So that is a trend right now. Okay. So now instead of writing to a customer support, calling them, you go there and then complain their Twitter feed, and there's actually a lot of activities going on in the sentiment analysis, all those things. Yeah.
Okay. Thanks.
Actually, maybe it will come one day that they will even look at your Twitter pages also. You never know. So not at this point. Okay. So earlier, if you maybe if you go back maybe 5 years or 6 years, there is a cleanup mechanism will be part of every system. Okay, deleting records from database after 1 year, 2 year, 15 days, and deleting files. That will be part of the system, right? That kind of that's important component those days. Now that is not even, while designing a system, they don't even consider cleanup mechanism, right? So because the storage is cheap or whatever it is, and also see the you can see that the data growth here, it contributing like a number of web pages, and there's a new thing is called IoT. So IoT is growing like anything, right? So I engaged in a couple of initiatives. I can tell you that one is smart home. So you have all your home is wired. You can control from wherever you are. Before you start from office or work, you can turn on AC, or whatever or heater or whatever it is, right? Also switching on your rice cooker. So later there's a company called Belkin. So they make a rice cooker. So through internet you can input everything there. Before you start, you say start. It will start cooking. By the time you reach, this nice hot food is ready for you. Right? So that's the thing. And also a lot of activity going on in agriculture. So other initiative we are discussing. So agriculture. So now there are a lot of things related to agriculture. It's a soil quality which will change, maybe depending on the rain or how much fertilizer you supply, moisture, various things, and also it's kind of what crop can grow there. So now a lot of sensors. There are also the equipments, right? What is it called? Tractor or whatever it is, right? So now how much seed it should, it's based on the quality of the soil. You should decide how much seed and what's the distance. All those things, farmers, they don't know. They end up, use excessive using, or they underuse it, right? So those kind of things. Now that initiative is going on, at least in India. So a couple of leading companies are doing that. So what they do is they connect sensors to wherever possible, collect it, and then they make intelligent decision, and then control the devices to do whatever it's supposed to do. Like, okay, maybe every 5 feet put a seed, or every 1 feet put couple of seeds, something like that, or how much water, how much fertilizer or pesticide, whatever, right? Those things can be done. So that's what IoT is growing really. A lot of sensors are everywhere, right? You collect data from various sensors and make things out of it. Number of users, I don't need to tell. Social, I don't need to talk about the Facebook updates. And also the things change, like how long the data is persistent, right? So we go to email and we delete our mail, right? We think the mail is gone, but it's not. They retain mail for 5 years for government reason and for various other things. Of course, they retain forever. For the big guys, they retain forever. Even though you delete, it's not deleted, right? So they can recover at any time. Right? So these things, like so it's impacting big time, and then so amount of data growth is increasing, and then the duration the data is kept also increasing drastically. You can see that. Okay, so yeah, traditional. What is the traditional? The property of traditional high performance system. So you go to any data center, you will see big Sun or IBM machines. 4 or 5 machines will be there. So that's a really expensive. Each machine costs around $500,000. So they it's mainly for computation. Like you can 64 GB RAM, 32 core machine. Now core is 32 is very common, even low-end machines. But yeah, those days, right? So they have high performance machines sitting there. They pay 10% maintenance cost and a special software you have to buy, whatnot. So a lot of things, right? They meant for CPU intensive and then processing small amount of data. So they have a lot of concurrent processing, the hyper threading, whatnot. All those things are it takes care. You use what the protocol, right? Shared memory, pipe, sockets, whatnot, So those kind of message passing, complex message passing concepts, and yeah, Unix, like we deal with Unix, you will come across these kind of things. People use it everyday life, especially in the high performance system, right? So now if you install some communication software, RPC or whatever it is, you can select what kind of mode you want to communicate. Is it socket or files or shared memory or named pipe, whatnot. So those things are there. So that's why it is like they choose right mode for communication and type of storage, everything depending on the type of problem they are solving, they code it to suit their problem. I'm going a little fast, but yeah, this is just more of an introduction kind of thing, right? So you stop me if you're in doubt. Yeah. Okay. So traditional process, how they do is they move the data. So you have NAS and SAN, right? So NAS is they are meant for storage. They take care of duplication, redundancy. Make even one disk crashes, you still have the data. These are all so SAN and NAS is very popular thing, right? You backup, right? If company backups always they give you a mount point, right? So that's nothing but sitting in a NAS or SAN, right? So that's how they store the data, and then the high performance system is sitting separately. Now what they do is they move the data from your storage to the high performance system. Whatever discussed we earlier, right? So, moving, processing, and then intermediate storing, intermediate results, and reprocessing, and then finally producing output. All those things are happening in the traditional approach. Also, so you have to develop algorithm to move the data, start a job, monitoring job, and coordinating job, and structure, right? It's a hard, you define the structure, and if they didn't change, you add a new field or change the data type. So you have to undergo a lot of changes, right? Also, fault tolerance and recovery, right? So there is no inbuilt fault tolerance or recovery, right? You have to build it, monitor, right? So those kind of things is your headache. Also, the handling redundancy, right? If so only one part fails, what do you do? Also, like storage redundancy, if the machine goes down, what do? You need to have a redundancy, something in your mind, before designing a system, depending on how critical it is. Okay, so this has been working fine so long, right? So what is so now why should we bother about it? These are the problems, right? The CPU power, you need more and more CPU power, more memory, more storage, the network bandwidth. This is you would have realized in day-to-day life. 1 GB file from your laptop to copy to a drive, USB drive. It takes what 10 minutes. And then think about from your some LAN move file from your machine to some machine. It takes really 20 minutes, 30 minutes, 1 hour, right? And same thing, right? When you deal with a large amount of data, so move machine data from your storage device to high performance system, it takes large amount of time, and then and also costs you a lot, right? So these are the main problems there. Hardware costs, right? These high performance machines, Sun and IBM machines are at least $500,000. So, and also maintenance costs and other software costs, right? So that's the problem. And here, let's say we have set up, we ran out of computation power or some of these things. What do? You add more CPU, more RAM, increase the bandwidth, more storage. That's what you do that. So there's a limit to that. Beyond certain point, you cannot do that, right? So you have to buy more machine, better machine, right? Or throw away that, buy a bigger one, right? Or scale out, right? Buy more machines, and then so solve the problem, right? So these are all the problems with the traditional approach. Okay, so yeah, that's a problem. Forget about it. Let's move on to there is something called 4 V's they talk about in terms of big data. So data at rest, that means like a huge amount of data, right? So huge amount of data sitting there, okay, and also like a lot of data getting generated, right? So this you understand, right? This how it is generated, we discussed that so the website visit, that's one thing, or you have a lot of sensors there, they keep sending information. Your application logs, right? That's a good example. So if you want to monitor real time what is going on, so application will be let's say the numerous servers are there, keep generating a lot of information. So you want to monitor real time monitoring. How would you do it? So a lot of data is there. You should have the ability to process it, right? And also we are talking about data, right? So you call so it's okay. Let me take a step back. So you have a structured data, which is nothing but database, dump a CSV file or whatever it is. You have proper structure. Semi-structured XML, JSON. These are all semi-structured data. From the schema you can figure out what is what. Unstructured data, whatever the written text. or the call IVR, when you speak to agent, call center agent, or whatever it is, right? Video, audio files, image files. So those are all unstructured data, right? So now, so remember I gave you example that you call IVR. From there also they do sentiment analysis, right? They convert into text, and then they do they extract things out of it, and then they build the meaningful profile of you, right? Right. Also, like so data in doubt. This is very common, right? So when you deal with the data, at least I always seen that there's a bug here and there. Some kind of a data analyst missed to analyze certain aspect. So the data comes in some non-usable form, right? And also it's corrupt, or maybe we never understood that the format or whatever it is, right? So data in doubt, this is like very common. Common. So these 4 V's, the main pillars of big data. So big data helps you solve all of these 4 problems. Okay. Example, I think we can move fast. So we already discussed Bing, and then search engine, the Google or Yahoo Bing, they crawl thousands of millions and billions of web pages, and then they build the index out of it. Advertising, so they target, okay, you go somewhere, you do something, let's say you travel, okay, make my trip, you went to make my trip, you did something, right? From that point onwards, maybe next 2-3 weeks, wherever you go, you see ad related to travel or tourism or something, right? So now they want to they know somehow figure out, okay, you are you are going to travel in next few days, and then by showing you right ad, you will the probability of you clicking on the ad is high, so that they can make money, right? Each click, it's let me tell you that in US, some clicks, like the law related things, lawsuit, work related injury, work related things, right? It's a $500 a click. Can you believe it? $500 a click. And then some like make money online, there's a keyword there. So that one, like we had 3 servers, 4 GB data to hold advertisers information at Yahoo, right? 3 machines, just 4 GB, 12 GB of memory to hold advertisers who are bidding on just the word make money online, right? So think about it. So certain words are popular, certain words are costly. So now for the important things, they figure out the travel is very one of the costly, and Hadoop training, it will cost you at least in India alone 500 rupees a click, right? So I think our friend can give you more information. So it's each word costs a lot of money, right? So now they should target right person, right? By showing you meaningless ad, you will not click, and then they will end up losing money. They are hosting a lot of servers, they're giving free search service, right? They don't make money out of it. By making you click on this text ads, they make money, right? So they need to find the profile, they show you right ad, right? Patient medical records, and then so even some logs. This is the thing. And then one other example is remember last year Google introduced a driverless car. So they built a car. It's from start, you keep ending point. It'll go by itself and then reach the destination without driver, right? So how do you think they would have made that, right? So how it started, this car will have a lot of sensors. So including gas, acceleration or brake or clutch or the steering wheel, and then sensors, red light, who is coming left and right, in front of you, back. So they will the actual driver is driving. So then they have the machine learning algorithm. So they learn. Okay, before that, let me take a step back. So for every second or every millisecond, microsecond, I don't know how frequent they collect data about your environment, right? So whether the light is green or yellow or red, or who is going there, how much the traffic is, all those things they collect, and then just they collect it, right? So then the data scientists, they build a model there. So using the existing information, they know that, okay, if you see a red light, and you are 50 meters away, probably you have to slow down and stop it, right? Or you are maybe 5 meter, you see yellow light, you should cross it. So those kind of rules, it learned by itself, and then they integrate that with that, and with the supervision, the feedback, right? Machine learning with the feedback, they keep refining the algorithm models, and then finally, one fine day you get 90% good rules and models, right? See, that's what they use, that 190% or 80% ready things, to make a car reach from one place to other place without a driver, right? So think about it, how much data they collect, how much algorithm or intelligence they have to use to build that rules and models, right? Mathematical models. So big data is, it's easy to do that. That's what, you can, you have the data, maybe you are not data scientist or statistician. So maybe within a week or two, you can be a reasonable, data analyst. Yeah, data analyst, data scientist is hot commodity. You don't get people in India, and it's highly paid, and it's a lot of opportunities there. This we discussed earlier, type of data. Okay, so the main thing is don't move data, right? So how to handle big data, right? So don't move data because it's costly to move the data. Move the computation closer to data, right? That means your program. So you get files or big files or whatever it is, store it, in right format. We will discuss about it. Then move the computation closer to where it is sitting, and then execute, get the results, aggregate, and done. You had to work in parallel. So here we discussed, right? So you solve the problem, by splitting into things, but still it's in one machine, correct? If it's a multiple machine, how can you coordinate, which process doing what job? Understand, right? So you have to work in parallel. You should be able to handle complex data set, structured, semi-structured data. You should be able to handle it. The platform you should be able to store, search, sharing with the external world. Transferring from one place to other place, analyzing functionality. That's what we discussed about the Google things, right? So analysis is this is really becoming popular. Wherever you go, they have data. They are analyzing, and they the gold nuggets. They are trying to search for gold nuggets everywhere, right? I can give you more example, but yeah, maybe if you have time, we can discuss later. Also, scale is the problem, right? So today I have 100 GB of data. Let's say this festival season, the 100 GB become 200 GB. How can I handle it, right? Or I need to instead of processing maybe 10 machine, I need more machine. Then how do I handle it? So this platform should support scale also, storage and processing scale, and also cost should be low. So you don't want to buy that big IBM machines, AX machines for processing. That's $500,000. So you use a low cost infrastructure or hardware for processing. So okay, so all these things available in one place. It's called Hadoop, right? So open source. There are a lot of equivalent things to Hadoop, but yeah, Hadoop is open source and it's becoming the standard. And I hear that Google also started using Hadoop. They got rid of their their own platform. Excuse me. Yes, these two. This is what we are going to discuss in the next 1 hour or so. So file system and MapReduce. So unlike the traditional system, the SAN, NASPA storage, and the computation is high performance system. No, it's all in one. We'll talk about it. The Hadoop can scale from one machine. You put it on your laptop, or you can build a cluster of 10,000 machines. So 10,000 is very common nowadays. It's written in Java. So if you write Java related Java programs, it will integrates well and performs well, but it's not mandatory. But you can write in any language, right? But actually it's a little bit slow, also a little bit cumbersome. You need to put extra effort in writing your job, the distributed job there. Right. So it uses commodity hardware, right? My PC, your PC, can link together and make a 2-node cluster. Maybe matter of 1 hour, half an hour, right? Yeah. So Hadoop is nothing but a file system, Hadoop distributed file system plus MapReduce. So what is MapReduce? It's so you traditional you have the procedures, functions, object oriented, the declarative SQL, declarative language, all those things. This is a concept MapReduce. So we will discuss about it. So you have to think your problem in different way. It's in terms of maps and reduces. We will cover that. So it's not your traditional way. So that is what the beauty is. So you approach the problem in different way, so that whatever problem we discussed earlier, right? All those things will be addressed automatically. You don't worry about the size of the data or number of machines, nothing. You write for one machine, it should work everywhere, right? So that is what the map reduce. Probably we will focus on that. Okay, so Hadoop is not, okay, probably will go fast, so it's not a data warehousing replacement for data warehousing system, but it could be a data warehousing. You could use it. It's not a file system. It will not replace your hard disk or whatever it is. It's not a database, but it is a database kind of features available, but it's not a database. It's not online processing. And so mainly, yeah, this is important. So for last 4-5 years, Hadoop was focused, or Hadoop was important for batch processing, not for real-time computation. That's not anymore. So I think last August or something they released Apache Strong. So that is for real-time processing. Same the MapReduce we are going to discuss, available for real-time processing also, and it is in beta state. I think it is still not in production ready. I think Strong, right? So we are not going to talk about it, but yeah, so keep that in mind. Like Storm is picking up another big thing, right? And also it's not replacement for programming language. So you cannot solve all the problems in this one. Most of the problems you can solve, but not all. So there are certain problems like shortest path algorithm that the state related, right? One state influences the next things, right? If there is a tight coupling between the state, it will not work there. Okay, so you can store anything: video, audio, text, unstructured, anything. Huge amount of data. There's a less cost because it uses commodity hardware. Scale, yeah, 10,000 machine cluster is is sitting there in the Yahoo side, Yahoo's things. You can store and you use the same infrastructure for storing and processing. That's the key here, right? So if you separate these things, it becomes very complex, right? This is the beauty of it, and this is what we are going to focus in the next few slides. And the built-in analytical processing. Let's say I know that there's a tool called OR, right? It's a modeling language. OR, right? So it has a limitation. It cannot work on more than maybe 10,000 rows or whatever it is. So it's very limited, and then it's kind of takes time to do the work. But the same OR is available on Hadoop, so that is much faster. It can work on huge amount of data, right? Those kind of things there, and parallelism. So the other one is the jobs, right? So unlike the traditional system, the jobs, so there was tight coupling between the jobs. There's there's always the communication, the message exchange between these two, and then one controls the other, those kind of tight coupling there. But here jobs are independent. One job died, whatever died or running, doesn't matter. Other job will continue running it, and if it's kind of there's no relation between, and somebody else will see what is going on, will control it, right? So that's what independent jobs are tasks are executed without state relation. That's very important.
Question.
Yeah, please.
On the previous slide, so we said that don't move the data, rather the processes to data one, and here Hadoop stores anything. So is it a storage mechanism by any chance?
It's both. Big data, we saw, right? Big data, the problems with big data, storage, computation, network bandwidth. We saw more, right? So yeah, these three are the important things, right? See, it addresses all of these things. In the next few slides, you will see that, right? Yeah. Okay, this is a slightly outdated slide. So the Hadoop got 1.x version. This 1.x, 2.x got lot more. So let me explain you a little bit. Then probably I'll tell you what is there in the 2.1. Right? This is the core. File system, MapReduce is all tightly coupled. So it's one unit. This is for storage. This is for computation. Okay. On top of it, you have a lot of other things, right? So here, this is like you are familiar with database, right? SQL. So you have a language like SQL kind of language. You can write your job, and also you can plug in your the user-defined functions. A lot of things are there, right? So what's happening is you write your problem in this language, automatically converted into MapReduce code by the compilers, and then that will be executed here, right? So the foundation is MapReduce and storage, right? And then the catalog is there. The HBase is NoSQL, inbuilt NoSQL database there. You guys familiar with NoSQL database? Okay, so let me give you maybe I don't want to take much of explaining much of time explaining that. So RDBMS, you know that I don't need to explain. You have normalization, tables, relation, all those things are there, right? There's a problem. There is a cost to that because it takes a long time to query it, licensing costs and scaling. So we have a lot of problems with that, right? So apply this big data logic to database. There also we have problem, correct? So this NoSQL database, it's also as you have query language, all those things you can do. It's a NoSQL. Yeah, it's not only SQL or something. That's a name is not important. So now the scale and whatever we are discussing for big data, the same problem applies for database also, and then the NoSQL database helping you. So there it's a normalization is not at all there. There you have acid theorem, right? So acid theorem is removed. So instead of that they introduce something like CAP. What? Probably we'll see that. We have time. We'll discuss about it later. So then there are a lot of management thing, monitoring that workflow, the coordination service. So a lot of things are there. This is again is for batch processing. It's not for real-time processing. Right? In 2.0, they introduced service called Storm. That's part of this one, right? It's for real-time processing also. Right? Anyway, so let's focus on this one. Let's make use of time, efficiently. Okay, so this is a Hadoop architecture, right? So you have one machine which is called master, and then numerous slave nodes. This is what thousands of nodes. It could be up to 10,000 is proved. Right? So the master is only one master, right? So it has two layers. One is for storage, one is for computation. Okay, so let's say you want to store a file. Right, or some of the data you have to make it available to this system, right? So this guy we'll discuss later. This guy helps you to move the data from outside into the whole platform. We will discuss in the next few slides. How data is stored, right? So that's what this is something called name node. Keep this in mind. Name node. We will discuss about it, and then the data node. So it's for storing. So the master also could be in a data node, right? So the data node is there on all the slaves, right? This is a mirror image of this one. So similar to name node, you have a job tracker. So all the jobs, whatever job you submit, it has to be through the job tracker. All the files you store into the system is through the name node, right? This is a mirror image. And look at this here. This guy is this guy takes care of storing the data on that machine. So these machines don't use any special storage file system or whatever it is. It's a native file system. If it's a Linux machine, whatever the storage supported by the Linux machine, or Windows, what is it? Not FAT, yeah, FAT, right? FAT is the file system. So it uses FAT. So it doesn't have any special things. It uses native storage mechanism. Okay, so here it's similar to storage. You have for processing. So you submit a job to this guy. This guy will distribute the job to all the task tracker, and task tracker will execute the jobs, and then we'll cover that later. So that's what same machine is used for both storing and processing, right? So in the next few slides, probably it will give you better. Okay. Okay. So anyway, don't forget about it. I'll summarize it. Maybe quickly. So you have what? 100 GB of file. You want to store it, right? So use the Hadoop that file system. That is store my file, right? Store, this is my file path. Store it, which is available. File is available somewhere, right? Or it's a real-time streaming, whatnot. Okay. This guy, right? So it takes that file, split that into chunks, blocks, right? What is the block size? By default, it's a 64 MB in a 1.x version. It's a 256 in 2.x, and it will be keep increasing. The machine power increases. I don't think I won't be surprised if within a couple of years the block size is 1 GB. I won't be surprised. Okay, so that's what block size is 64 MB right now. So they divide your file into 64 MBs and then store it in multiple machines. You understand? Blindly, if you put a line at the 64 MB location, split into chunks or blocks, and then store it in multiple machines. How we are storing that, we will see in the next few slides. Right? So yes, scalable, portable, all those things we will cover that. So the one problem you have to remember that there's a single name node, right? In the previous slide. Remember, there's a master, single master, right? So everything has to be done through this guy, right? Everything means I'll qualify what is that everything later. So that if this guy goes down, your platform is down. So that's a single point of failure. So that's a big thing, and a lot of work is going on to address that issue. So okay, so then the data nodes, right? These nodes, they talk to each other by some RPC communication. We'll discuss about it. Okay, so essentially it's storing across multiple machines. It's dividing into blocks, and then in a single point of failure, the client uses TCP/IP communication to talk to name node and name node, and then this RPC also it uses for communication, right? There's something called replication, right? Let me address this one. Let's say you store something. We discussed that you divide that into blocks, and you know what? I'm going a little fast, but I'm giving you exactly what you want at this point. So yeah, don't if you want to know more, please stop here, right? So because my goal is to cover what is the Hadoop map reduce and storage. That's why I'm skipping a lot of other details, right? Okay, so let's come back to replication. So you're storing something in one machine. The machine bad or hard disk crashes or what something happened and the machine is overloaded. What do you do that? Right? So now you lost the data, right? So to avoid that, it automatically takes care of replication, right? So replication, how many replication? That is configurable depending on the situation, right? Let's say you have only one data center, you have the maybe 100 machine cluster, maybe 3 replication. If you have the multiple data centers, geographically located, maybe 3 in the main data center, maybe 2 in the other data center, 1 in the other data center. So those things are the deployment aspects. Probably we will skip it. So the bottom line is multiple copies of each block is stored. We will see that in the next few slides. Yeah, so the goals of HDFS is like storing a large number of files, big files, commodity hardware. You don't want to buy the special hardware, Sun machines. You should be able to take care of the failures and recovery. Replication should be handled, and then it's meant for batch processing. Okay, so this one, like you write once. Use the file many times. It's not for go and change the third line fourth word or updation those kind of things. No, it is meant for write once, read many times. Okay, in the newer version, so update is possible. You can go and update at the end of the file. That is possible, right? So that's the main thing. And if you want to make the changes or do something with that file, you want to change the content. You have to throw away and recompute regenerate the data and then move it there. That's the only way there. Let's say you want to get the file, right? now you go to your disk and see that type the file or cat the file, you can see the content. Right? Here it's distributed across multiple machines. Right? How to handle it? The client will know will be the client. What you can write your own client, or you can use a Hadoop client to do that. So that can find the blocks and can access directly from the data node. Right? We will discuss about it. So this is about replication. So let's, for example, we have 60 MB of file. We are saying replication factor 3. So it divides into 3 chunks, right? And the 3 chunks are stored in 3 different machines. So any questions so far? Fine, right? Yeah.
So to store data into different machines, we need to have that special hardware like SAN environment.
No SAN, no NAS, no special hardware. It's all commodity hardware, local storage files, your storage. There's no mapping, mount point, nothing is there.
So later it will move to the actual storage, is it?
No mounting. Yeah? It's your storage. You buy a machine with half a TB of storage or 1 TB of storage. That's how it is.
My question is like we have this management software. For example, like when I have a network or SAN, we have a management software which basically collects all the data from the clients and stores.
You have the same thing here. This is the ecosystem. You go to bed tomorrow, you wake up, there's something else new sitting there. So this is like growing like anything. You have whatever the previous slide is. I didn't cover all the details. I remember that this slide. You have all those things there. Whatever you're talking about, and the Hadoop itself provide a lot of tools to monitor, to visualize what is going on. So you have plenty of this. This is just the tip of the iceberg. It is kind of you get into the Hadoop world, you will see a whole lot of things. Right. So your question is you want to know the management tools, all those things, right?
No, my question is like how this Hadoop ecosystem can fit into management software environment.
It's not for real time or something. It's batch processing. You have to understand that. So the 2.0 you have real time processing there. It's mainly for batch processing. So that means huge jobs there, which will take maybe hours or days, maybe some months to run. Those kind of jobs you will use it, right? So remember we talked about getting data from multiple sources, building a profile of a customer, right? So that is building a data warehouse, data mod, or let's say the other example is it's good that you brought up this question. So other example is, let's say, report generation. It's very common, right? Now you go there, you select various dimensions, you will see the report. Right? Let's say, for example, how many the company has the employee monitoring tool, right? How many people coming late, how many people on time, how many people took leave on that day, or average and retention rate. A lot of things they do that, right? This is reports. Let's say if you want to generate report or billing, like Airtel. Let's take Airtel, right? So you keep getting bills, right, every month. So how do you think they are generating? If they have to use the the special purpose system, so they have to scale up, they have to write special code to do that, right? And also they generate the bill to I remember that my previous employer used to run 3 days for just generating bills, and they keep complaining that okay, 3 days we lose a lot of money, cut down to maybe 1 day or less than that, right? So those kind of things, bill generation, all those things you can move it to Hadoop. It's mainly for batch job, so batch processing. Of course, yeah, the Storm is there, which can do real-time computation, but it's out of scope right now. Are you clear? So management software, you cannot do it because through which you cannot do that. Only number crunching and storing you can do this. It's mainly for file system and computation. Yeah. So management software does a lot of analytical work and a lot of processing work, right? Those things, yes, you can move it to Hadoop. Any questions so far? Right? I'm moving really fast, but yeah. So yeah, this is Hadoop takes care of it. Anyway, I give you just introduction to that. So the fault tolerance, we talked about it, right? So how it is organized in the real production system is there is a rack switch, and the multiple nodes are there, and then there is an aggregate switch, and that's how it is organized there. So this guy, so right, these are all commodity hardwares. So there is a property to that. So it stores in such a way that even the machine goes bad, or the switch goes bad, or the aggregate switch goes bad, you should be able to function properly, right? The replication is stored in such a way that any of these failures should not impact the system. Right? That's the goal. Okay. Okay, this is important. So this is application. So it's either a Hadoop commands, or you write your own application. Doesn't matter. You want to store a file, right? Okay. So if you store a file, after completing storing file, you go to name node, right? Let's say you had 4 blocks, right? 4 64 MB blocks. So block A, B, C, and D. You have 4, right? So here, forget about it. I'm showing this diagram captures for A and B, right? This guy, name node, maintains metadata about block E. Where all it's stored? It's stored in data node 2 and 3, right? So block B stored in 1 and 3. That is what's shown here, right? So this is a data node, right? And then this is a name node. So data node contains the actual blocks, right? So if you see that block A stored in 2 and 3, right? So replication factor is 2 here, right? And the block B also stored in 1 and 3, right? So this guy has the metadata, not actual data, right? Metadata. That's why if this guy goes down, the whole thing is gone, right? Now let's say this node, is something went wrong with the node, but still we have this one, right? So this guy, takes the moment the replication factor is 2, right? It knows how many copies it should maintain, how to maintain all those, the rack awareness we saw on the previous slide, right? It has algorithm to figure out how to move data here and there. All those things will take care of by itself. You don't need to worry about it. Right. Actually, in the next few slides, we will see how to read and write. All those things we will see that. Same thing we can skip this. Okay. So name node, it's a master we discussed earlier. It has the metadata about list of files, blocks, data node where it is stored, attributes, right? All those things are part of name node. It's a single point of failure we discussed. So here it detects actually, okay, so data node and name node, right? So there is a connection between these two. They exchange message every 3 seconds or something, right? So now the data node say I'm alive, I have these blocks. They regularly do a checksum verification. They validate things are good file system and other processing. They exchange a lot of information and how much load it is having, data node. All those things are shared with a name node. So that's the name node evaluates the quality of the machine. If the machine something is not good enough for the system, it will remove from the cluster by itself, right? And also notification, a lot of things are there. It will take care of it. So right, you see, it takes care of the balancing disk usage. Let's say one disk one machine used heavily. It figure out that okay, so too many blocks are sitting here, and let's move it to some other block, right? Those things are taken care of automatically. Communication also, let's say the too much communication going on between this machine and the client. So it will aggregate over a period of time. Will figure out that okay, this is a very critical data. Maybe we should distribute in such a way that network usage or machine access load will be reduced, right? So those things are done by the name node. Any question on name node? This is important. You should understand name node. Good, right? Yeah. So how it is stored? We will skip it. If we have time, we will come back. Okay. Data node, it takes care of storing, retrieving, distribution. So a lot of work. Most of the work is done by the data node. So since we have only one master, so that node has to be really sleek and it should be very efficient, otherwise it cannot handle the load, right? So yeah, but most of the work is done by this guy. So it's a slave cluster. Yes, we discussed that it changed with the name node about what it has right now. So okay, the other thing is the replication, right? It doesn't go through the name node, right? Let's say name node decided that okay, the data from this node should be moved to some other node, right? Let me take a step back. Name node figured out that this particular machine is overused, right? It has to move one block from one machine to other machine. It decided that, right? It simply communicates to the name nodes, the corresponding name nodes. You give up this block, you take ownership of this block. It informs the two name nodes. That's all it does. Then it will start monitoring the progress. Then these two data nodes coordinate each other. Then they exchange they move the block from one data node to other data node. And then once the name node confirms that okay, the move has been successful, using that every 3 seconds it exchange the messages, right? So once the name node confirms that okay, the guy got the destination, the block has reached the destination, it informs the other node to delete the file, right? So that's what it is. That's what it uses heartbeat to exchange the details every 3 seconds. Yeah, the same heartbeat is used for detecting failures, all those things. Any question on data node? So you're clear, right? We discussed about name node and data node, right? Yeah, we can skip this break. Just some time. So we talked about the single point of failure, right? To address this, there's something called secondary name node. It's not that hot, the name node goes down, secondary node comes alive. It's not that. So manually you have to intervene, to make it up and running. Yeah, probably we will not discuss about it, but yeah, but in the actual class we will discuss about it maybe for 20-30 minutes this alone, right? So yeah, and for time being, I'm not going to discuss about it. Maybe after the class, if you want to know more, we can I can stay back. Yeah, so let me give you a little introduction. So this is a name node, right? So okay, I think I'm forced to explain. So name node, right? So whatever you do with a name node, storing a file, deleting a file, changing the replication factor, or changing the block size, whatnot. Whatever changes you do is going to affect the file sitting there, right? Like database, all those things are recorded as a log. Not actually is going to make the changes right away. Right? It's just the whatever changes, right? The name node makes the data node makes changes. This guy will update its main memory, right? And also just put a log record what it did, right? It's okay. Just the changes, text change is updated to a file, right? The FS image, right? This is what's sitting in the memory. When you start a cluster, it uses FS image. It says it has all the metadata, right? Where we discussed the name node metadata, right? Remember the files in the blocks and the data node or replication factor. All the things are available in FS image. So when the node is operational, this will be keep changing. The changes are only updated in the memory. This is not touch its read-only file, right? So nothing is happening here. So now if the node crashes, if something goes wrong, you lost all the changes, right? That's not acceptable, right? But that's why we have edit logs. When you switch on the machine again, it uses the previous image and then the current edit logs. It combines these two and then create a new FS image and then use that one, right? So to do that, it takes long time, right? So that's why there's a secondary name node is in the picture. This guy, once in a while, talk to the name node, gets the edit log, and then the FS image, and then build the FS image, push the FS image to the name node. It does that. But still, it is not up to date, right? So So when the system, when you stop or when your system crashes, when it comes back, it has the latest FS image. Maybe it was created 10 minutes back or 5 minutes back. Then apply the log changes here, and then this guy creates the new FS image. Right? So yeah, so to reduce time, the secondary name node is helping the primary name node. Any question? So yeah, this is really summary of what it is doing, but a lot more to it. Okay, let's take a break. We'll come back. So what we covered is we covered storage things in brief. So we will discuss about the job tracker and then task tracker, which is equivalent of name node and data node. Then we will see how to read and write file, how to write a MapReduce program. You can solve the Java program, whatever we discuss, we will solve it in a MapReduce. Right? Let's take a 5 minutes break. Yeah,